All right, what I'd like to do is translate some word problems into algebraic expressions. Okay, so algebraic expressions just means using variables for different types of quantities that we don't know yet. So let's just go through a couple of these and hopefully the patterns will emerge on the style of what approaches we can use to make expressions given these word problems. Joey has W marbles. So Joey has W marbles. We don't know how many marbles, so we're going to just say W. Could be 100, could be 5, we don't know. So Joey has W marbles and Mandy has 0.4 W marbles. So this is how much Joey has. And Mandy doesn't have quite as many marbles. She has exactly 0.4 W marbles, okay? And Joey gives 1/5 of his marbles. So I guess they're gonna be giving some marbles to this other person. This other person, this third person, we'll call Mark, cousin Mark. So Joey gives 1/5 of his marbles. So this is representing Joey's marbles. So when 1/5 of it would be 1/5 W. You could also say that's 0.2. 0.2 is the same thing as 1/5. So 1/5 of his marbles, as well as Mandy giving 2/3 of her marbles. So if this is Mandy's marbles, then we're gonna do 2/3 of Mandy's marbles. It's gonna look a little weird, but by the way, 4/10 as a decimal can be written as 4/10 as a fraction, okay? So this is Mandy's marbles, 4/10 times W, and Mandy is giving 2/3 of all of her marbles, which is 4/10 W. Okay, write an expression for the number of marbles Mark receives. So we can do a little bit here. By the way, 4/10 is the same thing as 2/5, so we can reduce right away. 2/5. And now, using PEMDAS, we know that we need to multiply before we add. So let's multiply this. So this is 2 times 2 is 4, 3 times 5 is 15. I would like you to put that on a different line below, but obviously I'm running out of room, so I'm just going to erase here. So 4/15 W it is. 4/15 W, 4/15 W. And now we have like terms. Do you see that these are both W's? They're not W squares or anything like that. There are no Z's, they're just W's. So if I have 4/15 W, I can add that to 1/5 W. And by the way, if you add fractions, you need to have common denominators. Looks like 15 is going to be a common denominator. I multiply 3 times 5, make 15, and I multiply 1 times 3, and I get 3. So 3/15 plus 4/15 is 7/15 and W. And by the way, you could write it like this. You could also write it as 7W over 15. Okay? You could write it that way as well. They are both equivalent. Just remember not to put W in the denominator. If you're going to put it anywhere that's not really big on the outside of the fraction, you need to put it in the numerator. And then we could figure out what 7/15 was as a decimal and then just write, you know, whatever that decimal W. But this is totally fine. Let's leave it at this and move on. Okay, what are the problems that we have? 60% of the difference of 5/18 x subtracted from 4/6 m. Okay, wow, that's, whew. All right, let's try to translate this one. Okay. 60%, so 60% looks like this, but when we're multiplying, we need to turn it into a decimal. And the way that we turn percents into decimals is you take the hidden decimal point, which is always going to be right here, okay? And we're going to move it to the left 2 spots, okay? So that's how you turn a percentage into a decimal. So that's 0.6. So 0.6 is the same thing as 60%. Okay, now we can just have that. 60% of the difference of, okay, difference means subtraction. We're doing a subtraction problem here. Okay, so 60% of The difference of something. Okay, so we need to find out what that subtraction problem is. The difference of 5/18 k, 5/18 k, okay? By the way, this k can be out front, really big, or you could, if you wanted to, you could write it as 5k over 18. Either way is fine, but do not put the k in the denominator. So it's the difference of 5/18 k subtracted from, so we're subtracting this from something. We're subtracting it from 4/6 m. And again, m can either be really big out front or in the numerator, but never in the denominator. Okay, so, so this is, correctly, it is the difference of 5/18 k subtracted from, do you see that? We're subtracting it from 4/6 m. So we'll do that. By the way, 4/6 can be reduced to 2/3. So if you can reduce, you should reduce. Make things easier. Okay, so now we had 60% of this whole difference. So now we just got to pop this into our parentheses. 2/3 m minus 5/18 k. All right, and so that is our expression. Since we don't know what m is and we don't know what k is, that's as far as we can go, all right? And that's totally fine. We have just translated a word problem into algebraic notation, okay? Let's do another one. Okay, Freddie paid $W for a camera. We don't know how much he paid for a camera, so we're just gonna call it W. W, so we'll say the money Freddie paid for a camera, all right? Could be $150, could be $1,000, we don't know. Okay, so Freddie paid $W for a camera and $120 for additional camera lenses. So we do know that he paid whatever it was the cost of the actual camera plus $120 extra for the camera lens. If the sales tax is 8%, how much did Freddie pay for the camera and lenses, including all of that sales tax? Okay, so this is what he has as sort of the principal that he pays. Meaning that's what when he goes to the store and he picks up the item of the camera as well as those extra lenses, okay, that is the money that is going toward just the camera and the lenses. Unfortunately, or fortunately, however you think about it, we have to pay sales tax, okay? Unless you maybe buy things off the internet sometimes. But anyway, if you go to an actual brick and mortar store, you're gonna have to pay sales tax of whatever the local jurisdiction is asking to have sales tax on. So this particular jurisdiction has an 8% sales tax, okay? So that means for every dollar that you pay in actual merchandise, you're gonna have to pay 8 cents extra to the government as a tax, okay? So we don't know how much money this is in all, but we do know that you would need to add the camera plus the lens to get your total amount of money that you owe just for the actual merchandise, not the tax. Okay, but of course when you get to the cash register, this is not the number that rings up, okay? It'll ring up this plus 8%, okay? So what you would need to do is, there's actually 2 ways to do this. What I would do is, so we're gonna multiply this. Well, we're gonna have to pay this, so we'll have to multiply it times 1, because we need to pay this, plus we need to multiply it times 8%, okay? So this is correct of what you need to pay. Or if you want, you could distribute this over, and that's fine as well. So I would accept this, by the way, but if you want to distribute it out, it would be 1.08 W plus whatever 120 times 1.08 is. Okay, excuse me for a second, I just need to do this. 8900000021. Okay, 06912. Okay, so 1.08 times 120 is $129.60. Okay, so these two are equivalent statements. They are equivalent expressions. So you leave it like this, or you could actually multiply it out. But either way, that's what you would pay. Now, why is it 1.08? Well, so think of this as 108%. So 1.08 equals 108%. Remember, to take something that is a percent and turn it into a decimal, you go to the left twice. To take something that's a decimal and turn it back into a percentage, you move it to the right twice, okay? So this is saying 108% of the total amount. Well, think of it. You have to pay 100% because you're not stealing the stuff. So you have to pay 100% of just what the camera and the lenses cost. You're paying 100% of whatever that is, plus 8% more for tax. Now, we have an 8% tax, so that's why we need to not pay 100%, but we're actually paying 108%. You may think it's fair or not, but that's how it works, okay? In terms of living in a place where we need things that sales tax revenue raises for the community. But that's the political thing. The point is there is 8% in this case that we need to pay, so we need to pay 108% of the actual merchandise cost, so that's why we multiply it times 1.08, okay? I think that's enough for today. I'll give you some extra questions that you can keep translating, and we'll work more on this in class. Thanks.